Welcome to the Explainer. Today, we're completely demystifying local network routing mechanics. Look, if network traffic ever feels like a bit of a black box to you, or maybe you just want to seriously sharpen your technical diagnostic toolkit, well, you are in the exact right place. We're going to break down exactly how your devices talk to each other and, more importantly, how they find their way out to the outside world. So let's kick things off with a classic networking mystery. Have you ever wondered why a computer can talk perfectly fine to a local office printer, sending documents back and forth without a single hitch, but then suddenly it completely fails to load even a single website? It's an incredibly frustrating scenario for anyone, and honestly, a super common headache for support specialists. Well, by the end of this explainer, you aren't just going to know exactly why this happens. You're going to walk away with the exact step-by-step framework to solve it, every single time.
Section 1. The Network Exit Door. Okay, let's dive into this.
So, what exact mechanism do your devices actually use when they need to reach out beyond their immediate surroundings and into the vast expanse of the internet? Enter the default gateway. This is simply the IP address of the local router that connects your local area network, your LAN, to external networks. Think of the default gateway as the essential exit door of your network. Actually, scratch that, it's more like your local post office. Whenever a device wants to reach an IP address that isn't on its own local network, it doesn't really know how to get there by itself, so it just hands that data packet straight over to the default gateway. The gateway's entire job is to take that packet and route it out to the rest of the world.
This brilliantly illustrates the absolute golden rule of traffic flow. With local LAN traffic, it's literally just like staying inside your house. If you want to talk to someone in the living room, you just walk over and talk to them, right? In networking, local devices talk directly to each other without needing any special routing help. Your computer talks directly to that printer across the room. But remote traffic, well, that's like trying to send a package to another country. You can't just toss it out the front window. You have to physically drive down to the post office. In our network environment, that means your computer absolutely must bundle up its data packets and send them directly to the default gateway first, before they can travel anywhere on the remote internet. Section 2. Drawing the boundary line. Let's move to this and see how it builds.
Because, once you understand the concept of that exit door, the logical next question is, how exactly does your computer mathematically know if a destination is inside the house, or if it needs to use that exit door to head to the post office? That brings us to the subnet mask. It's a 4-number combination used by a device to separate its network part from its host part. And this isn't just a string of random numbers, it is the absolute crucial boundary line. Without this mask, a computer literally cannot calculate its own identity. It relies on this exact numerical calculation to figure out if another device it wants to talk to is sitting locally on the same network, or if it's remote and requires passing data off to the default gateway.
Now, what's really interesting about this alignment matrix is how you can think of it mathematically, almost like a secret decoder ring. Notice how the IP address lines up directly over the subnet mask. The logic here is beautifully simple. Wherever you see the number 255 in the mask, that defines the network part. In this case, the 255s perfectly align under the 192, the 168, and the 1. Think of that section as the street name. Then, that 0 at the very end, that defines the host part. That's your specific device, basically acting as the house number on that street. By sliding this mask underneath its IP address, your computer instantly calculates its exact coordinates and knows precisely where its local neighborhood ends.
Section 3. The Ultimate Diagnostic Weapon.
Okay, so we've covered the fundamental theory of how traffic moves and how these boundaries are drawn, but now let's step into the field. Imagine a user tells you, I can print to the local office printer, but I can't open any websites. Every single field tech, IT support specialist, and telecom installer encounters this classic customer complaint. It is the absolute perfect real-world test case to apply what we just learned about the exit door and the boundary line.
When you face that specific scenario, the very first thing you do is execute what we call the gateway test. It's incredibly straightforward but profoundly revealing. Step 1. Open your computer's command prompt. Step 2. Execute a simple ping command directly to the default gateway's IP address. You're essentially yelling down the digital hallway to see if the exit door is still standing there and capable of answering you back.
And there are basically 2 possible outcomes to that test. If the ping is a success, it means your local path is perfectly healthy. Your computer can reach the local router without an issue. Therefore, the problem is external. It's further down the telecom line, or maybe there's a service outage with the internet service provider. But if the ping is a failure, your device cannot even talk to its own router. the local LAN is fundamentally broken. So the crucial point is you immediately know to stop calling the ISP and instead check the physical location for disconnected cables, completely incorrect IP settings, or an unpowered router. This single, rapid test instantly isolates exactly where the network failure lies, which is going to save you massive amounts of time.
Section 4. The Golden Field Rule. Let's look at one last critical detail. Let's wrap up our technical toolkit with a vital piece of field wisdom regarding standard home network configurations. 90%. That is a massive number, and it represents a massive reality in consumer networking. I really want you to firmly keep this statistic in mind. To put that into perspective, 90% of all standard home internet installations strictly expect and use the 255.255.255.0 subnet mask. It is the undisputed golden standard for home environments across the board.
And because of this standard, if you're ever looking at a home router configuration and you spot an anomalous mask, like say 255.0.0.0, that is a massive red flag. Because of those strict boundary rules we learned earlier, configuring a home setup with that specific mask will instantly disrupt internet routing. The devices are going to get super confused about what's local and what's remote, and the connection to the outside world will just completely break. So, golden rule, always verify the mask when you're troubleshooting.
So, what does this all mean? I'll leave you with this final question. Next time a device completely fails to reach the outside world, will you check the boundary line before you knock on the exit door? You now have the exact blueprint to do just that. Master the default gateway, always verify that subnet mask, and run your ping diagnostics with absolute confidence. Thank you so much for joining me for this explainer. Keep learning, keep troubleshooting, and I'll see you in the next one.